in this question, let's see what they have said. If theta plus pi is the eccentric angle of a point on the ellipse, they have given us equation of ellipse as 16x square plus 25y square is equal to 400. Then what they have asked, the corresponding point on the auxiliary circle, they have given us 4 options here. Okay, how are we going to do this? Well, first of all, we have to write the equation of ellipse in a known form, which is the standard form. And how we are going to do that? We'll divide this entire equation by 400. Right? So when I do that, I'm going to get x square by 25 plus y square by 16 is equal to 1. This is my equation of ellipse in standard form. Clear? Okay, so let's start from here only. We have already seen the equation of ellipse as x square by 25 plus y square by 16 is equal to 1. Now guys, you know this much, that the center will be origin. So from here I can say that my a value will be 5 and b value will be 4. That means a is greater than b and this will be a horizontal ellipse. Clear? So let's take a case. We have a horizontal ellipse like this. Now there is an auxiliary circle. Auxiliary circle is a circle which will have the same center as that of the ellipse. Right? And what is the radius of that? Well, the radius of auxiliary circle is nothing but length of semi-major axis. That's correct. So I'll have an auxiliary circle like this. Okay. This much is known to you very well. Now, I have to find a point on auxiliary circle, and it is not just any point, it is the corresponding point of a point on ellipse whose eccentric angle is theta plus pi. So let's draw it. I have a point P here on the ellipse whose eccentric angle is theta plus pi. Right? Now, you know this very well that the corresponding point on the auxiliary circle will lie just below this point P. Let us say this is my P dash, which I have to find out. And you also know one more thing, that for P dash, my parametric angle for the circle will be nothing but same, that is theta plus pi. This much you know very well. That means for my circle whose center is nothing but origin. And guys, can you quickly tell me what is the radius? Well, we have already seen that for auxiliary circle, the radius is nothing but 5. That is length of semi-major axis of the ellipse. So I have a circle whose center is at origin, whose radius is 5 and whose point has parametric angle as theta plus pi. You know the parametric coordinate. It is r cos the parametric angle, that is r cos theta plus pi, comma r sin theta plus pi. Isn't it? R cos theta, comma r sin theta. Well, here the theta is actually theta plus pi. That is the parametric angle. And guys, this you know very well. What is cos of pi plus theta? Cos of pi plus theta is minus cos theta. Similarly, sin of pi plus theta is minus sin theta. That's correct. So that means my final corresponding point on the auxiliary circle is going to come out as minus 5 cos theta, comma minus 5 sin theta, and this is going to be the final answer of this question. Have you understood? Very well. And if we see the options here, we can say that B is going to be the right answer. Well, in this question, what they have asked is the equation of tangents to the ellipse. Ellipse equation is 3x square plus 4y square is equal to 12, which are parallel to the line 2x minus y plus 5 is equal to 0. They have given us 4 options here. Now guys, before actually solving the question, let's consider the options which are given. What they have said in the question, that tangent is parallel to the line 2x minus y plus 5 is equal to 0. That means my slope of tangent is equal to 2. Right? Okay. So if I quickly see the options here, my A option will have the slope of line as, you know the slope of line. It's minus coefficient of x divided by coefficient of y, isn't it? So guys, what is the slope in option A? Well, in option A, the slope is 3. That means this cannot be the answer. In option B, the slope is 2. That means it might be the probable answer. But let's consider C and D also quickly. So in C option, you know the slope, well, it is nothing but minus of 16 by 22. Well, it is not equal to 2, right? Therefore, C also is not the answer. And in D, 2x plus 2y, you know the slope of this line is minus 1. That means the only possibility which we have is B. And that has to be the right answer, right? So sometimes before solving the question, what we can do is, we can actually eliminate the wrong options like we did here, and we know the answer has to be B. But let's solve it out also to reconfirm. How we are going to do that? I have a tangent whose slope is 2 because it is parallel to my line 2x minus y plus 5 is equal to 0. And what is the ellipse? Well, the ellipse is in standard form. And how we knew that? Because if I divide the ellipse equation by 12, it's going to come like x square by 4 plus y square by 3 is equal to 1. You know here that a value is 2 and b value is root 3. That means a is greater than b, and this is a horizontal ellipse, right? Center will be at origin. Clear? Okay. So a figure will look something like this. I have a line. I will have two parallel tangents. How can I say that? Well, you have already learned that I have two tangents of same slope. They will become the parallel tangents. So I'll have two here which will have the same slope. And I have to get equation of these tangents. And how are we going to do this? Well, I have information about slope, isn't it? The slope here is equal to 2. And if I have information about slope, I can use slope form of tangent. That's correct. And guys, quickly, let's recall what is the slope form of tangent to the ellipse. Well, it is y is equal to mx plus minus root over a square m square plus b square. And you have to remember this, right? Okay, so this is the slope form of tangent with us. I have the slope information that it is 2. And we have seen that my a value here is actually 2 and b value is root 3. So quickly putting all the values, let's see what do we get. So I'll get my equation of tangent t as y is equal to m. In place of m, I'm writing 2. So it's going to become 2x plus minus root over a square m square. So a square is 4. M square will again be 4 plus b square, that is 3. 4 into 4 is 16 plus 3 is 19. That means I'll have the equation as y is equal to 2x plus minus root 19. Or you can write this equation also as 2x minus y plus minus root over 19 is equal to 0. This will be the equation of tangents, and you can see this very clearly that I'll have two tangents, one with plus, another with minus, and they are going to be the parallel tangents. Clear? Understood? Perfect. And if we see the options here, we can say that option is B. We have got the B answer, which we have just seen by eliminating the options also. Understood? Moving further, let's see what they have said here is, in this question, you have to find the equation of tangents to the ellipse, whose equation is 3x square plus 4y square is equal to 12, which are perpendicular to the given line y plus 2x is equal to 4. Okay, so again I have to find the equation of tangents, but here what they have given, that tangent should be perpendicular to the given line y plus 2x is equal to 4. Now guys, for perpendicular, what I'll do? Well, I'll first find slope of this line. Now y plus 2x is equal to 4, you know the slope is nothing but minus 2, right? Minus coefficient of x upon coefficient of y. Okay, so if my line is having slope minus 2, guys, can you quickly tell me what is this slope of tangent? Well, we have the relation. What is it? It is m1 m2 is equal to minus 1. That's correct. So if I do that, I'm going to write something like this. m1, which is my equation, which is my slope of tangent multiplied by m is equal to minus 1, right? And if I put my m value as minus 2, you can quickly tell me value of m1 is going to come out as 1 by 2. That's correct. That means I have slope of tangent with me. I have to write the equation. And before doing that, we'll quickly also go by elimination of options. Yes, that is a quicker method. So if we do that, let's start from option 1. In option 1, we already know the slope of line is 1 by 2. That means it can be a probable answer. Coming to option B, y is equal to 2x plus minus 2. We know the slope of this line is m is equal to 2. Not at all possible. Coming to option C, I have 2y is equal to minus x plus minus 4. Slope of this is minus 1 by 2. Again, not a possibility for us. Left is option D. So guys, quickly, what is the slope of line in option D? Well, in option D, the slope is minus 2. That means D is also not possible and we are left again with option A. That has to be the right answer. Clear? So this was done by elimination of options. You have to do nothing. But suppose if I have to solve and get to the right answer, how will I do that? Equation of ellipse can be written like x square by 4 plus y square by 3 is equal to 1. How? We'll divide the equation by 12 and the tangent slope came out as 1 by 2. Right? How? Because it was perpendicular to the given line y plus 2x is equal to 4, which we have just seen. So I have A, I have B, I have M. So which form of equation of tangent should we use? Can you make a guess? Well, there is none other than slope form of tangent. That's correct. And guys, what is the slope form of tangent? Well, it is y is equal to mx plus minus root over a square m square plus b square. Very well. You remember it. So, what are you waiting for? Quickly just substitute all the values and guys, let's find answer. So, when I put my m value as 1 by 2, it's going to become y is equal to x by 2. Plus minus root over a square. We know the value of a square is nothing but 4 multiplied by m square. Now since my m is 1 by 2, m square will be 1 by 4 plus b square is nothing but 3. So this is going to come out as this 4 is going to get cancelled and 1 plus 3 is nothing but 4. So I'll get square root of 4 as y is equal to x by 2 plus minus 2. Or further you can say that it's going to come out as 2y is equal to x plus minus 4. This is going to be the final answer of the equation of tangent. Whenever information about slope of tangent is given, we are mostly going to use slope form of tangent only. Understood? Very well. And if we see the options here, what is the answer? Well, the answer is A, right? Which we have just found out by elimination of options. Understood both the procedures? Both the methods? Very well. Well, moving further, what they have said here is we have to find slopes of common tangents of the ellipse and the circle. Ellipse equation is x square by 4 plus y square by 1 is equal to 1. The standard equation of ellipse and the circle is x square plus y square is equal to 3. Now we know that both the ellipse and the circle will have the same center. Yes, origin, isn't it? So I have a horizontal ellipse. How can I say that? Well, you already know what is the value of A, guys, for the ellipse. The value of A is 2. The value of B is 1. A is greater than B. That means it will be a horizontal ellipse. So this is a horizontal ellipse for us. And what is the radius of circle? Well, the radius of circle is how much? Root 3. That's correct. So I have my radius of circle as root 3. So my circle will be like this. We all can write the vertices and the extremities of minor axis for the ellipse, right? The vertices you can directly say it will be 2, 0 and minus 2, 0. And the extremities of minor axis will become 0, 1 and 0, minus 1. Clear? Okay, so this much we know. I have to find the slope of a common tangent. Now guys, what do you mean by common tangent? Well, a tangent or a line basically which is touching both the ellipse and the circle. or I can say that a line which is tangent to both the ellipse and the circle. So let's take a line will be something like this. It is tangent to both the ellipse and the circle, and thus it is called common tangent. Clear? I have to find slope of this common tangent and match with the options. Understood? Very well. Now, the figure, we have already seen this will be the figure, this will be the common tangent which I have to find out. Now comes the question, how can I actually get the slope? Well, to get the slope, I have to use which form of tangent? Well, it should be the slope form, right? So, what is the slope form of tangent to the ellipse? Let's discuss that first. You know what is the equation of slope form of tangent? I hope you have learned till now. It is y is equal to mx plus minus root over a square m square plus b square. Right? So this is my equation of tangent to the ellipse. Similarly, I can also write the equation of tangent to the circle. Yes, the circle is nothing but x square plus y square is equal to 3. We know the radius here. The radius value r is equal to root 3. So, in terms of slope, the equation of tangent is nothing but y is equal to mx plus minus r root over 1 plus m square, isn't it? This will be the equation of tangent to the circle again in the slope form. Now, since these two lines are same, I can actually compare, and when I compare, I know that my y is same in both, mx is same in both. That means the constant also should be same. So, I can directly equate the constant term, isn't it? So, what am I going to do now is, I'll just equate the constant terms, that is root over a square m square plus b square should be equal to r root over 1 plus m square, right? Okay, now we know a square. What the value of a square is? Well, a square is 4 and similarly b square is 1. So guys, quickly put the values and let's find the slope. Let's see who gets the answer first. So it's going to become 4m square plus 1 root over is equal to root 3 multiplied by root over 1 plus m square. And to get the value of m, let's do the squaring. So it's going to come out as 4m square plus 1 is equal to 3 plus 3m square, isn't it? And from here, guys, what are you getting the value of m square? Well, I am getting the value of m square as 2. That means the final answer should come out as plus minus root 2. Got it? Very well. I also got the answer. And if we see the options here, we can say that B is going to be the right choice. Understood? A simple question, isn't it? Well, moving further, what they have said here is, if the tangent to ellipse is given in the standard form, x square by a square plus y square by b square is equal to 1. So this tangent is going to meet the axes, that means the x and y axis at A and B. Then what is the locus of midpoint of AB? They have given us options here. That means let's consider a case if my A is greater than B. We all know this will be a horizontal ellipse, isn't it? So we'll have a horizontal ellipse like this, and I have actually drawn a tangent at, let us say, some random point. So I'm drawing a tangent like this. It is going to intersect my x-axis, let's say at A, y-axis at B, and I have to find my midpoint locus. So my midpoint of A and B, let's say here is M, and I'm taking the coordinates of M as h comma k, right? To get the locus, we do that. So I have to find locus of this point M, which is lying on the tangent. Clear? Okay. How are we going to do this? Well, we have already seen the figure. M is the midpoint of A and B. If I have to get coordinates of point M, definitely I have to get coordinates of point A and B, right? And what is A and B? Well, A is x-intercept of the tangent and B is y-intercept of the tangent. And to get x and y-intercept, guys, obviously I have to write the equation of tangent first, isn't it? Now, which is the best form you can actually imagine and write the equation? Well, the best part will be the parametric form, isn't it? It will have only one variable, that is theta, which I have to eliminate. So guys, Do tell me, what is the parametric form of equation of tangent? Well, it is nothing but x by a cos theta plus y by b sin theta is equal to 1. That's correct. Very well, you remember it. Good. So this is the equation of tangent. Let me take this as t. Now, quickly guys, what is A and B? Let's find out. A is the x-intercept. You know, to get the x-intercept, I have to put y as 0. So it's going to come out as A by cos theta, comma 0. Similarly, my B will be the y-intercept, and for that I have to put x is equal to 0. So it's going to come out as 0, comma B by sin theta. And if I have A and B, I can write the midpoint, isn't it? So I can say that my midpoint M, which is nothing but h comma k, will be, when I have to write midpoint, you know the formula. It's x1 plus x2 by 2, comma y1 plus y2 by 2, isn't it? So when I do that, I'm going to get midpoint of A and B as A by 2 cos theta, comma B by 2 sin theta. And if I actually compare h comma k to the given point which we have just found out, we can directly say that h value will be equal to a by 2 cos theta and k value will come out as b by 2 sin theta. Now, I have cos theta, I have sin theta with me. How can I eliminate theta, guys? Well, we have learned one relation between cos theta and sin theta in the very earlier classes. What was it? Cos square theta plus sin square theta is equal to 1. Bang on. This relation we are going to use here. We'll quickly write the value of cos theta. We can say that cos theta will be equal to a by 2h, and similarly sin theta will be equal to b by 2k. And we know the relation cos square theta plus sin square theta is equal to 1. So we are going to substitute the values of cos and sin here. So when I do that, it's going to become a square by 4h square plus b square by 4k square is equal to 1. And guys, to write the final answer, we know h has to be replaced by x and k has to be replaced by y. So when I do that, the final answer is going to come out as a square by x square plus b square by y square is equal to 4. This is going to be final answer for this question. Understood what we have done? Very well. And if we see the options here, we can say that B will become the right answer. Understood, guys?